Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand basic configuration of OSPF version 3. See, there are two types of OSPF version 3. One which support only IPv6 routing. Like if I will talk about OSPF version 2, there are many similarity between OSPF version 2 and version 3 and some differences as well. So we will discuss what is the difference in version 2 and version 3. There are many differences like differences in LSAs, like in configuration. So we will discuss about those things. But what I am saying that we have two types of OSPF version 3. One which support only IPv6 routing and one support both IPv4 as well as IPv6 routing. So we are discussing the OSPF version 3 which support both IPv4 as well as IPv6 routing. Means here we have address family features to configure routing for IPv4 and for IPv6. So we can configure routing for IPv4 also and IPv6 also. But mainly we come up with OSPF version 3 for IPv6 routing and we have OSPF version 2 for IPv4 routing. Okay, but as I told you, nowadays we can use use OSPF version 3 in IPv4 routing as well and in IPv6 routing as well. Like OSPF version 3 is compatible with both IPv4 as well as IPv6. So guys, without wasting our time, let's begin the scenario. First, in this video we are going to understand the basic configuration. Maybe in our next video, in the day 2 of OSPF version 3, we will discuss the LSAs of OSPF version 3 and prerequisite to understand OSPF version 3 is you should have knowledge about OSPF version 2, because I am going to teach you OSPF version 3 with the reference of OSPF version 2. Like we will discuss LSA 1 in OSPF version 3. So I will tell you that what is LSA 1 in OSPF version 2, because there is no difference between LSA 2. Very few differences is there between version 2 and version 3. But still, if you don't know what is router LSA in OSPF version 3, it will be very difficult for you to understand LSA 1 in OSPF version 3. So prerequisite is you should have knowledge about OSPF version 2. Now guys, without wasting our time, let's begin the topic. See, I have this topology today. In this topology we have 5 router 1, router 2, 3, 4, 5. Router 1 belongs to area 1, means all interface of router 1 belongs to area 1. You can see 0.0.0.1. Router 2 have one interface in area 1 and one interface in area 0. So router 2 is my ABR router. As you know, router whose at least one interface belongs to area 0 and at least one interface belongs to area any other regular area, that type of router is ABR router. And router 3 is my backbone router. Like router 1 is regular router 2 is ABR router 3 is backbone router, because all interfaces of router 3 belongs to area 0. So this type of router is ABR router in OSPF version 2 also and in OSPF version 3 also. Then router number 4, again router 4 have one interface in area 0 and one interface in area 2. So this router is ABR. And router 5 is internal router, because all interface of this router belongs to area 2. Both interfaces of this router belongs to area 2. So this router is my internal router. Fine, router 1 is internal router 2 is ABR router 3 is my backbone router 4 is again ABR router, and router 5 is internal router. First of all, see the IP configuration. I have already configured the IP address between routers. Like between router 1 and router 2, I am using this IPv6 subnet 2001:db8:12. Between router 1 and router 2, I am using 12 :0/64. Not, it is not 0, it is like /64 and here also it is 2001:db8:23:/64. And between router 3 and router 4 also we are using this subnet 2001 colon db8 colon 34 colon double colon 64. Between the router 3 and router 4 I am using 34 double colon slash 64, and between router 4 and router number 5 I am using 2001 colon db8 colon 45 double colon 64. Okay, so these are the IP configuration, and one LAN is connected with router number 1 and one LAN is connected with router number 5. Here on in this LAN I am running this subnet 2001 db8 colon 10 double colon 64 0/64, and here 2001 colon db8 colon 20 double colon slash 64. Fine. Now without wasting our time, let's begin the configuration of router, means OSPF version 3 on routers. See guys, configuration is here, the basic configuration. Before enabling OSPF version 3 on router, you have to run this command, IPv6 unicast routing. First of all, we need to enable IPv6 unicast routing and on router, then only we can configure any routing protocols. So to enable OSPF version 3 on router, first we need to enable IPv6 routing. After that we will run command router OSPF version 3 process ID. Like if I will talk about OSPF version 2 configuration, so in OSPF version 2 we run this command, router OSPF and then process ID, let's say 1, and this is the command to enable OSPF version 2. And command to enable OSPF version 3 is router OSPF version 3 and then process ID, let's say 1. After that, as you know, here on these routers I am not running IPv6 address, IPv4 address. On all interfaces of routers we have configured IPv6 address only. So these routers don't have IPv4 address, but in OSPF version 3 also router ID of router is in the form of IPv4. Like router ID can be 1.1.1, router ID can be 2.2.2, right, in the format of IPv4. So here on router number 1 you have to configure router ID. So here we will run command router ID. If manually we will not configure the router ID, as you know, the automatic process of router ID election is first it will check highest IP address on loopback interface. If loopback is not exist, then the highest IP address on physical interface will become router ID. But if we don't have any IPv4 address on the loopback interface or physical interface, we have to configure router ID manually. So in this scenario we need to configure router ID manually. Like on router number 1, let's say router ID is 1.1.1.1, and then to enable OSPF on interfaces you have to go to interface, let's say interface fast ethernet 0/0, and then we will run command OSPF version 3. OSPF version 3, instead of OSPF I am saying OSPF version 3, then process ID, after that IPv6 and area 0. In OSPF version 2 command is OSPF 1 area 0. Command to enable OSPF on interface is IP OSPF 1 area 0. This command enable OSPF version 2 on the interface, right? And to enable OSPF version 3 on the interface, we are not going to define IP here. Directly we will say OSPF version 3 and then process ID, then IPv6 area 0. So these are the very basic command to enable OSPF on routers, and there are verification command as well. So we will see how to verify the configuration of OSPF version 3. Before that, let me enable the OSPF version 3 on router number 1. So command on router number 1 that I am going to run is first is IPv6 unicast routing, then router OSPF version 3, then let's say process ID is 1. I'm going to say router ID 1.1.1.1, and then interface fast ethernet 0/0, or we can use range command, interface range fast ethernet 0/0 and fast ethernet 1/0. Here on these two interface I am going to run this command OSPF OSPF version 3, process ID 1, IPv6, area 0. These two interfaces are in area 0. So these are the command to enable OSPF version 3 on router number 1. So let me copy this command here, and I am going to paste this command on router number 1 in the console of R1. So here I have console of all routers: router 1, router 2, router 3, router 4, and router 5. If you want to verify, if you I can show you the IP configuration. So IPv6 interface brief. So you can see on fast ethernet 0/0, this is my IPv6 address. On fast ethernet 1/0, this is my IPv6 address, and these are the link local address. Okay, so here on router number 1 I am going to paste this command, and see, without running IPv6 unicast routing command, if I will run command router OSPF version 3, OSPF version 3 and process, let's say 1. Okay, so we have not enable IPv6 routing here. I think IPv6 routing is enabled on router number 2. Let me run this command router OSPF process 1 and say no router ID, because see, this router is not able to elect router ID, right? Because here we don't have any IPv4 addressing. Okay, so this is the command, this is command to enable OSPF version 1. I am going to remove this command, and to enable OSPF version 3 you will run command router OSPF version 3 and then process ID, and see what it's saying. OSPF version 3 IPv6 unicast not enable. So first we need to enable IPv6 routing. So on router number 1 IPv6 routing is enabled, that's why this command is accepted in the console. Right now here first command is this one, very clear, router OSPF version 3 and process ID, let's say 1, process ID, let's say 1, and then router ID, let's say 1.1.1.1. Only these two commands you need to run. And then how to verify the configuration? So IPv6 protocol, we can run this command, and in so IPv6 protocol we are not able to see any routing protocol. Here you can see routing protocol is OSPF process 1. IPv6 routing protocol is OSPF process 1. So now on this router I have defined the router ID as well. Now we are going to enable OSPF on interfaces like interface fast ethernet 0/0. Here I can say OSPF, not IP, OSPF version 3, process ID 1, IPv6 and area 0. Fine. Then interface fast ethernet 1/0, OSPF version 3, process ID 1, IPv6, area 0. And now to verify OSPF version 3 is enabled on how many interfaces, on which interfaces, we can run command so IPv6 OSPF interface brief. So this command will show you the OSPF version 3 enabled interface. Like OSPF version 3 is enabled on fast ethernet 1/0. It is using process ID 1. This interface is in area 0. And here you can see interface ID is different from OSPF version 2. In OSPF version 2, here you will see the IP address of this interface like 12.1.1.1 or whatever IP address is configured on that interface. But here we have this concept also, interface ID. We will discuss about interface ID maybe in upcoming video. And after that, cost over here is 1. State, it is waiting for DR and BDR, and the neighbor is going to be on fast ethernet 0/0. So definitely this interface is 0/0. After that, fast ethernet 0/0 and fast ethernet 1/0. OSPF version 3 is enabled on these two interfaces. I am going to configure now router number 2. On router number 2, first is IPv6 unicast routing. Until and unless you will not enable IPv6 routing, you cannot configure OSPF version 3. Then router OSPF version 3 and process ID 1. Here router ID is, let's say, 2.2.2.2. and then to enable OSPF on interfaces, what I will do, interface fast ethernet 0/0 I will say OSPF version 3, process ID 1, IPv6 and area 0. So after some time you will see neighborship will come up between router 1 and router 2. Yes, you can see the log message. OSPF version 3, process 1, IPv6, neighbor 1.1.1 on fast Ethernet 0/0 from loading to full. So we have now neighborship between router 1 and router 2. To verify the neighborship on router number 1, we can run this command. So IPv6 OSPF neighbor. So you can see 2.2.2.2 is neighbor of router number 1 here. Okay, fine. Now which router is DR? DR BDR election is exactly same like OSPF version 2. So on router number 1 what we can do, so IPv6 OSPF interface fast Ethernet 0/0. If I will run this command, here you can see a state of this interface is DR, priority is 1, right? Similar like OSPF version 2. Okay, so router 1 is my DR, router 2 is my BDR. Fine. Designated router ID is, where is designated router ID? Yes, designated router ID is 1.1.1, means router number 1. Backup designated router ID is 2.2.2.2. So these are similar like previous video, like means like previous version of OSPF version 2. Date time, wait time, these are also hello time, these are also exactly same like OSPF version 2. Now I am going to configure OSPF. I am going to enable OSPF on fast Ethernet 1/0 of router 2 interface F1/0 of router 2. Here I am going to say OSPF version 3, process 1 and area OSPF process OSPF process 1, IPv6 and area 0. So this interface is in area 0, and you can see this interface is in area 1. Here I think this interface I have configured 0/0 also in area 0, but 0/0 should be in area 1. So let me correct it. And on router number 1 also I think I have configured both interface in area 0. So IPv6 OSPF interface brief. So yes, here we have configured these two interface in area 0, but these two interface should be in area 1. So let me correct it. Here what I am going to do, router, not router, interface range fast Ethernet 0/0 to 1/0, 0/0 to 1/0, and do so run interface fast Ethernet 0/0. I'm going to remove this command. This command, where is the command? Here it is. I'm going to remove this command, say no to this, and then I'm going to say OSPF version 3 IPv6 area IPv6 area OSPF 3 process 1 IPv6 and area 00001, we can say. Done. Now so IPv6 OSPF, so IPv6 OSPF interface brief. Now you can see this interface is in area 1 and this interface is also in area 1. And now on router number 2 also I need to correct the configuration. So I am going to say interface fast Ethernet 0/0, no OSPF version 3, process 1 IPv6 area 0. Done. And then route OSPF 3 process 1 IPv6 and area 1. This interface is in area 1. After that again you can see neighborship is up between router 1 and router 2. Then interface fast Ethernet 1/0 OSPF version 3 process number 1 IPv6 and area 0.0.0.0. This interface is in area 0. Once I will advertise this interface in area 0, this router will become ABR router. So IPv6 protocol, here we can say in the output of so IPv6 protocol, this router is area border router. This router is area border router. This is similar like OSPF version 2. Now let me enable OSPF on router number 3. So on router number 3 also you can see both interface of router 3 belongs to area 0. So first let me configure router OSPF version 3 and then process ID. Here IPv6 is not enabled, so let me say IPv6 unicast routing, and then router OSPF version 3 process 1 router ID 3.3.3.3, and then let me enable OSPF on interface range F0/0 and F1/0. On these two interface I am going to say OSPF version 3 process 1 IPv6 and area 0. Now we will have one neighborship between router 2 and router 3 also. Yes, you can see we have neighborship between router 2 and router 3, and how to verify neighborship. So IPv6 OSPF neighbor. So who is neighbor? 2.2.2.2 is neighbor, and on router number 2 if you will run this command, so IPv6 OSPF neighbor. So router 2 have two neighbor, 1.1.1 and 3.3.3.3. Fine, everything is correct till here. On router number 3 we have enabled the OSPF. Now let me enable OSPF on router number 4. So first I need to run IPv6 unicast routing command, IPv6 unicast routing, and then router OSPF version 3 process ID 1, and then say router ID, let's say foot.4, and I am going to enable OSPF on interface 0/0 OSPF version 3 process 1 IPv6 area 0. 0/0 is in area 0, so let me advertise it in area 0, and then interface fast ethernet 1/0. This interface is in area 2. So OSPF version 3 process 1 IPv6 and area, let's say 2 or 0.0.2. Done. Now here on router number 4, so IPv6 OSPF interface brief. So OSPF is enabled on both interface. You can see 0/0 is in area 0 and F1/0 is in area 2. Right here state is waiting. Let me configure OSPF now on router number 5. On router number 5, configuration is very easy na? Because most of the thing is similar like OSPF version 2. So router OSPF version 3 and process ID 1. So IPv6 unicast routing is not enabled, so IPv6 unicast routing, then router OSPF v3 process 1 and router ID, let's say 5.5.5.5, and after that we need to enable it on interfaces. So interface range F0/0 and F2/0. These two interfaces are in area 0. So let me say OSPF version 3 process 1 IPv6 area 0.0.2. Done. Now we will have one OSPF neighborship between router 4 and router 5. Yes, you can see the log message. And now I am going to verify the routing table that router 5 have received the LAN network which is connected with router number 1 or not. So IPv6 route OSPF. This is the command to verify routing table of IPv6. So here you can see we have some prefixes with symbol OI. We have actually on router number 5 all prefixes, router 5 have received all prefixes with this symbol OI symbol. OI is nothing but inter area, because these all prefixes are inter area prefixes. Okay, and you can see this router have received this network also 192, sorry, I'm saying 192, 2001:db8:10:/64, right? And distance is 110, distance is 110 and metric is 5. Why metric is 5? Because you 1 2 3 4 and 5. Cost on this link is, see on router number 1, we will discuss about these things also. So IPv6 OSPF interface brief, here cost on fast ethernet 1/0 is 1, here you can see cost is 1. So 1 is the cost of this interface, 1 is the cost of this interface R2 receiving interface, 1 is the cost of R3 receiving interface, 1 is the cost of R4 receiving interface, and 1 is the cost of R5 receiving interface. So total cost is 1 plus 1 plus 1 plus 1 plus 1, that is 5. So router 5 have learned this prefix, and router 1, let me verify the routing table of router 1. So IPv6, so IPv6 route OSPF. So yes, this router have also received this network 2001 colon db8 colon 20 slash double colon slash 64, and you can see distance is 110 and metric is 5. Like distance is similar like OSPF version 2. Now how to check database? And guys, to read database, before checking the database, first see the routing table on all routers. Like on router number 1, this is the routing table. Here all prefixes are with symbol OI, and OI is nothing but inter area. Here also you can read OI is nothing but inter area prefix. If I will talk about the prefix notation in OSPF version 3, let me talk about the OSPF version 2 first. Some prefixes are in OSPF version 2 with O symbol, means it is intra area prefix, intra area prefix, right? And we will have some prefix with O symbol, means with same area prefix, right? Some prefixes with OI, right? We have some prefixes with E2, means external prefix, E2, E1 external prefix, N2, and external NSSA prefix, NSSA external prefix, N1. These are the prefix notation in OSPF version 2. But if I will talk about, see, O means same area prefix, this is inter area prefix, and there is one more symbol, OIA, inter area prefix, this is same area prefix, means intra area prefix, this is inter area prefix, this is external prefix with metric type 2, this is external prefix with metric type 1, this is NSSA external prefix with metric type 2, this is NSSA external prefix with metric type 1, right? So these are the prefix notation in OSPF version 2. If I will talk about OSPF version 3, so again we have some prefix with notation O, then OI without a space. We don't have a space here. You can see on R1 routes we don't have a space between O and I. And then if I will talk about the next prefix, so it is can be O E2, it can be O E1, O N2, or EO N1. These are the notation of prefixes in OSPF version 3, right? Similar like OSPF version 2, but here we don't have a space. Okay, so on router number 1, you can see these all are inter area prefixes, right? So that's why symbol is OI. On router number 2, so IPv6 route OSPF. So here we have some prefix with symbol O, means this is intra area prefix, some prefix with symbol OI means inter area prefix. Like you can see this prefix 2001 colon db8 colon 10 double colon 64, means R1 is advertising this to router number 2, and sorry, R1 is advertising it to router number 2, and R1 and R2 are in same area. Like fast Ethernet 0/0 of R2 belongs to area 1. And if I will talk about this prefix, which router 5 is advertising to router number 4, and router 4 is advertising to router 3, and router 3 is advertising to router 2. So router 2 is getting inter area prefixes. So symbol is this one. Okay, in the same way on router number 3, if I will run command show IPv6 route OSPF, so here also you can see all prefixes. Router 3 is receiving all inter area prefixes. Router 3 have not received any inter area prefix because both are directly connected with router number 3. Fine. On router number 4 also, so IPv6 route OSPF. Here also we have some inter area prefix and some inter area prefix, right? And on router number 5, we have all inter area prefixes. We don't have any inter area prefix. And finally, let me verify the connectivity between LAN to LAN. So from router number 1, I am going to, let's say, ping 2001 colon db8 colon 20 double colon 1 and say source is, let's say, fast ethernet 1/0, which is my LAN interface. From the LAN interface I am able to ping this IP address. That means end-to-end reachability is there. We don't have any problem with reachability. So this is how we configure OSPF version 3 on router. These are the very basic configuration. If I will talk about the messages, guys, so in OSPF version 2 we have hello message, we have DVD message, database description. If I will write here, we have multiple types of messages in OSPF version 2, like hello message, like DVD message, database description, then we have LSR, then we have LSU, and then we have LSAC. So these are the messages of OSPF version 2, and these are the messages of OSPF version 3. We don't have any difference in the messages. If I will talk about the multicast address, which is very important. If I will talk about the multicast address of OSPF version 2, so as you know, OSPF version 2 send their messages like hello message, DVD message, right? Hello on multicast. On what multicast address? On two multicast address, 224.0.0.5 and 224.0.0.6. And if I will talk about the multicast address of OSPF version 3, so as you know, in IPv6 all multicast addresses start with FF02. So FF02 double colon 5 is the multicast address, and FF02 double colon 6 is the multicast address of OSPF version 3. So what I can do here on router number 1, I can run one command, so IPv6 interface fast ethernet 0/0. So you can see this interface is joined to multicast group FF02 double colon 5 and FF02 double colon 6. So these two multicast addresses are reserved for OSPF version 3. Okay, and if you will capture any link to check, it is sending OSPF hello message on what multicast address. So you can see here, if you will capture the link fast ethernet 0/0, let me capture this link here. And you can see the hello message. It is sending hello message on what address? FF025. Okay, so this multicast address is reserved for OSPF version 3. I am going to close it. And now next thing can be, it is sending like on router number 1 we have one LAN interface. So router 1 is sending hello message from their LAN interface also, because OSPF version 3 is enabled there. So it will send OSPF messages from their all enabled interface. So we need to configure passive interface. How to configure passive interface in case of OSPF version 3? Let me show you. On router number 3, simply you need to run this command, first router OSPF version 3, OSPF version 3 process 1, and after that we can say passive interface fast ethernet passive interface. Here we can say passive command is not there. Router OSPF version 3 process 1, router OSPF version 3 ID1 and then passive interface. Passive interface, let's say fast Ethernet 1/0, fast Ethernet 1/0, and now this interface is configured as passive. Or we can run passive interface default command also. It will enable passive interface on their all LAN interfaces. So we have some problem here. So IPv6 OSPF neighbor, so neighborship is fine here, and so IP OSPF interface fast Ethernet 1/0 first. So IPv6 v6. Okay, so here we can see the timer, these things, and let me show you one more thing here, more interesting thing. So IPv6 protocol, here we have information about passive interface or not. No, here we don't have any information about the passive interface configuration. So what we can do to verify, we can run this command also. So run section OSPF version 3. So passive interface configuration is, I have run passive interface configuration or not here. Interface router OSPF version 3 process ID 1 and then passive interface fast Ethernet 1/0. Now so IPv6 protocol. So IPv6 protocol, here we don't have any information about the passive interface configuration, but what we can do here, on router number 1 we can run this command. So IPv6 interface fast Ethernet 1/0. By running this command you can see, one thing here. So IPv6 OSPF interface fast Ethernet 1/0. This command is, I think, hello message. So you can see no hello message. This interface is configured as passive interface. So from this interface router is not going to send any hello message. Now in the same way on router number 5 also we need to configure one interface as a passive interface. So router OSPF version 3 process 1 and say passive interface fast Ethernet 2/0, and if you will check, so IPv6 OSPF interface fast Ethernet 2/0. So from this interface no hello message, no hello. Okay, so this is the configuration of passive interface. Now I want to show you the database, right? We will discuss about the database in next video, but in this video just only I am going to show you the database. So IPv6 OSPF database. If this is the database of router number 1, guys, in the router 1 you can see inside the database, this is database for area 1, and how many LSA 1 is there, how many LSA 1 are there, 2 number of LSA 1 are there, because you know 2 routers are there in LSA 1. This is similar like OSPF version 2, 2 number of LSA 1, because we have 2 router 1.1.1 and 2.2.2 in this area. Then how many LSA 2 are there, 1 LSA 2 are there, because between router 1 and router 2 link is fast Ethernet, and as you know by default network type on fast Ethernet link is broadcast. So there will be DR and BDR election. Definitely DR and BDR is not required here, so we can change the network type. I am going to show you how to change network type also in case of OSPF version 3. But how many, for now how many LSA 2 is there, only 1. Okay, and then this is, you can see new LSA 3. How many LSA 3 is there, 1 2 3 4, because you can see in different area how many prefixes are there, 1 2 3 and 4. One LAN is connected with router number 5, one network between router 4 and router 5, one network between router 3 and router 4, and one network between router 2 and router 3. So router 2 will share these all network in the form of LSA3. So that's why we have 4 number of LSA3 on router number 1. Then we have this new LSA, that is LSA 8. We will discuss about this LSA, and LSA 9. Okay, so these two LSAs are new LSA in case of OSPF version 3. In the same way, on router number 2 also you can verify the IPv6 OSPF database. Inside the database, except LSA 8 and LSA 9, rest LSAs are same, right? On router number, and any router you can verify it. Now let's discuss about the network type, how to change network type. See, on router number 1, fast Ethernet 0/0, so IPv6 OSPF interface fast Ethernet 0/0. So network type over here is, network type on this interface is broadcast. Network type is broadcast. But as you know, here I have used fast Ethernet link to connect to router, so this is point to point connection, so your network type should be point to point. So question is how to change it. Command is similar like OSPF version 2. You need to enter on the interface, like interface fast Ethernet 0/0, and here on this interface you will run command OSPF version 3 and then network, and whatever network type you want to configure, point to point, broadcast, non-broadcast, point to multi-point. So let me say point to point. On router number 2 also I'm going to say interface fast Ethernet 0/0 OSPF version 3 network, point to point. And now on router number 1, if you will verify the neighbor table, so IPv6 OSPF neighbor, so you can see this time neighbor is full and there is no DR and BDR. There is no DR and BDR because network type is now point to point here. So IPv6 OSPF interface fast Ethernet 0/0, interface fast Ethernet 0/0. Now you can see network type is point to point over here, and cost is 1. So this was the small video and basic configuration of OSPF version 3. We discussed some differences between OSPF version 2 and version 3 also in this video. In next video we will talk about LSAs. If I will talk about LSA, so in OSPF version 3, so guys, we need to learn 9 types of LSA in OSPF version 3. Let me give you the name, like router LSA, LSA1 is router LSA, similar like OSPF version 2. Then we have again network LSA, similar like OSPF version 2. Then we have inter area prefix LSA, this is LSA3, okay, in OSPF version 3 as well as in version 2. In version 2, what we call to this LSA, summary LSA, right? In OSPF version 2 we called LSA3 to summary LSA, but here in OSPF version 3 we call LSA3 to inter area prefix LSA. And if I will talk about LSA4, so LSA4 is called inter area router LSA, inter area router LSA. If I will talk about LSA5, so LSA5 in OSPF, okay, first of all, in OSPF version 2, what we call to LSA4, ESBR summary LSA, and here we called it inter area router LSA. After that, if I will talk about the LSA5, so LSA5 is called external LSA, ES external LSA. Here also we called it ES external LSA. After that, if I will talk about LSA6, so in OSPF version 2 also LSA6 is group membership LSA. Here also we call LSA6 to group membership LSA, which is not in used on Cisco IS LSA. On Cisco IS we don't use LSA6 MLSA. And then LSA7, So LSA 7 is called type 7 LSA here. And if I will talk about LSA 8, so LSA 8 in OSPF version 2 is called opaque LSA. So here in OSPF version 3 we called LSA 8 to link LSA, link LSA. And if I will talk about LSA 9, so LSA 9 in OSPF version 2 is also called opaque LSA, but here we called it as inter area prefix, inter area prefix LSA. So we will discuss about the LSA later, not in this video. That's all for today. Today we understand only the basic configuration about OSPF version 3. Guys, if you have learned something from this video, please hit on like button. If you have not subscribed the channel, please subscribe the channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today. Thanks for watching.